Okay, in this video we're going to be introduced to a new functional group called an epoxide, and we're going to talk about how to name these compounds as well. So we can have cyclic ethers of various sizes, where we have a ring system where the oxygen is part of the ring. In this video, we're going to be specifically interested in the three-membered ring. And when we have this three-membered ring, this compound is called oxirane. And we can put substituents on oxirane, and when we do that, a substituted oxirane is also called an epoxide. Now, the reason we're interested in this type of ether, and the reason this ether kind of gets its own special name, is because while most ethers are not very reactive, due to the large amount of ring strain, epoxides are very reactive. So there are actually a lot of ways to name epoxides, and if you Google it, it can be kind of confusing. We're going to focus on two methods for naming epoxides that I think you'll encounter most often. So in the first method, we're going to treat the oxygen, or the epoxy, as if it was a substituent. And we need to give two numbers for its locants. So both carbons that the oxygen is attached to will provide the numbers for. Now, one difference between epoxies and other substituents is we don't put it in alphabetical order. It always comes right before the parent name, like we do with the cyclo prefix. Now, unlike alcohols, the epoxy substituent does not get any special priority in the numbering. And so it gets treated, just like chloros or methyls or ethyls in determining the numbering. It doesn't get any special priority. Right, so we have two examples on the right here. So if I was going to name this with the epoxy group as a substituent, I'd find my longest chain like I normally would. And so in that case, I can make a 5-carbon chain. Right, and then I want to number from the side that's going to give the first substituent the lowest number. So I'd rather start numbering from this end, where the first substituent, I have two things coming off carbon 2, whereas I went from this way, I'd have two things coming off of carbon 3. Right, and then we do put the ethyls and methyls that are coming off the parent chain in alphabetical order like we normally would. So it would be 3-ethyl and 2-methyl, right? But then we don't alphabetize the epoxy. It always comes right before the base name. And we need to give two numbers, right? So the epoxy is attached to carbons 2 and 3, so that's why it's 2,3-epoxy pentane. Right, in this example, my longest carbon chain is 3, and when I decide the numbering, right, whether I numbered from this end or this end, the first substituent would be at 1, and I have one substituent each on 1, 2, and 3, or 1, 2, and 3, so they're sort of tied, right? And if you remember, when we're tied in this way, where I can't determine just by the numbering, then I go alphabetical. So because the chloro comes before the epoxy, right, this number, this would be number 1. So it's 1-chloro, 2,3-epoxy pentane. All right, the second way of naming epoxides, in this method, we treat the three-membered oxirane ring as the parent chain, and then we label the substituents coming off that parent chain. And the oxygen always gets number 1. And then, whether it's 1, 2, 3 or 1, 2, 3, depends on the normal naming rules, right? We want the first substituent to be as low as possible, and then we would use alphabetization to go next. And so when I'm naming this compound, right, the reason this gets 2 is both of these carbons have two substituents. So I'm going to have 2, 2, 3, 3, regardless of what I do. And then to break that tie, I go alphabetical. So the E comes before the M. So I number it in this way, 1, 2, 3. And so this would be 2, 2-diethyl, 3, 3-dimethyl, oxirane. All right, so we're going to finish off with 4 different examples of naming these epoxides. And in each case, if I can, I want to name it both ways. And so if we do it the first way, where the epoxy is a substituent, I first need to find the longest chain. And I think however I do it, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, right? I'm going to get a hexane however I do it. And then because this molecule is very symmetric, it doesn't matter which end I start numbering it from. So I'm just going to go 1, 2, 3, 4, 5, 6. And then coming off the main chain, I, of course, have the epoxy at 3 and 4. And then I have an ethyl also coming off both carbons 3 and 4. So this would be 3,4 diethyl 3,4 epoxy hexane. All right, in the second way of numbering it, I'm going to treat, right, the oxirane as my parent chain, and then all these ethyls coming off are going to be treated as substituents. Right, again, I could, because it's so symmetrical, I could number it 1, 2, 3 or 1, 2, 3. It doesn't really matter. So I'll number it 1, 2, 3. And so then my name is going to be 2, 2, 3, 3 tetraethyl oxirane. All right, let's look at another example. All right, so now I have an epoxide coming off another cyclic ring. It turns out this is really hard to name the second way, to name it as an oxirane. And so we're just going to name it, when we have the epoxide coming off another ring, I think the only reasonable way is to name it the first way, where we're going to name the epoxy as a substituent. Now in this case it's pretty easy because this is the only substituent, and so wherever it goes, these are going to be carbons 1 and 2, and so I don't actually even have to give numbers in this case, because wherever it is, that's just going to be 1 and 2. So all I have to do to name this is, it would be epoxy, no numbers are needed, cyclopentane. Okay, here's a similar example to the last one, only now I have additional substituents coming off the cyclopentane besides just the epoxy. And so now I'm going to have to worry about the numbering. And so when I number it, right, I think the two reasonable options would be 1, 2, 3 or 1, 2, 3. Right, remember, the epoxy doesn't get anything special in terms of numbering. So if I make this carbon 1, then my numbers would be 1, 1, 2, 3. Right, and that's lower than 1, 2, 3, 3. So I want to start numbering from here. And so then this compound would be 1, 1 dimethyl 2, 3 epoxy cyclopentane. Oh, got my dash there. Okay, one more example, and we'll finish up this video. All right, I wanted to do this one specifically because they're showing us the stereochemistry here. And so when they show us the stereochemistry, when we name it, we want to be sure to assign the configuration. If they hadn't showed me the stereochemistry, then we can't figure out the configuration, and we wouldn't have to worry about it. But when they go through the trouble to show me the stereochemistry, we need to be sure that we assign whether it's R or S. Now, usually when I have to assign configurations, when I do the naming, I usually name the rest of it first and then figure out the configuration of the chiral center at the end. And so that's what I'll do here. Now, this we don't have the epoxide coming off a cyclic chain or a cyclic parent, so we can name this one both ways. So the first way of naming the epoxy as a substituent, I need to find the longest chain. So I think that would be along here. Right, and then I want to start numbering from this end so my substituents are as low as possible. So I have 1, 2, 3, 4, 5, 6. And I have, of course, the epoxy and the 2 methyl groups. And so I'm going to have, right, remember the epoxy always comes before the parent chain. We don't have to worry about alphabetization. So I have 2, 3 dimethyl 2, 3 epoxy hexane. Now, for determining the configuration of the chiral center, I need to assign priorities. So let me change colors here. So I know the oxygen is going to be priority 1. Then I have 3 carbons attached, right? Because this carbon's attached to an oxygen. That's going to get priority 2. Then the propyl will be priority 3. and the methyl will be priority 4. Now remember, when we're assigning the configuration, in order for this to work and using the clockwise counterclockwise, the 4th priority group has to be on the dash, right? And that's not the case. And when it's a hydrogen, it's kind of easy and I don't have to redraw it. But when I'm assigning chiral centers where none of the groups are hydrogens, I think it's always better to kind of redraw it and be careful in assigning the configuration. So, right, our initial configuration is 1, 2, 3, 4. Right? If I swap any two groups, then the configuration is going to be the opposite. So if I switch the 3 and the 4 and leave the 1 and the 2 alone, whatever this configuration is going to be the opposite of what my actual configuration is. But because in this one I have the 4 in the back, I can actually assign this one. So this is 1, 2, 3. And so we're going counterclockwise. So this is S, but that means our original configuration was R. So our compound is in fact R. And so to finish off the name, we'll put that in front. It's R2,3-dimethyl 2,3-epoxy hexane. All right, so finally for the second way of naming it, right, where I treat the oxirane as the parent chain, I need to name the substituents coming off. So both carbons have 2 groups coming off, and so then I would use alphabetization to determine the numbering. And so I have methyl, methyl, and then this one methyl and propyl. So I think the 2 methyls beat the methyl and the propyl in terms of alphabetization, so I think I need to number it 1, 2, 3. So then my compound is 2, 2, 3. Trimethyl, 3-propyl, oxirane.